Okay, for 2a, it wants us to draw a line that passes through points 1, 5 and 3, 11. And to save time, I already did it right here. So we have 1, 5 right there and 3, 11. Lines drawn through it, and with that line we are able to identify other points. Alright, and that's what they want us to do for 2b. Label 3 other points on the line. Okay, so we can just start with the one in between. When x is 2, y is 8. So that point is 2, 8. And I'm just going to go down the list. 1, 5 is already identified. So next one, when x is 0, y is 2. Alright, so that's 0, 2. When x is -1, y is -1. Alright, so that's -1, -1. Alright, so that's 3 right there. If I want to keep on going, I can. If x is -2, y is -4. Okay, and those aren't the only points. Depending on how long you drew your line, how big your graph is, you may be able to identify additional points. Alright, 2c, it wants us to make a chart or a table of all the points that lie on that line. Alright, so I have my table right here. It starts with -5, then -3, -1, and then kind of goes in sequence all the way to 5, and then we got 10, 20, and then in general, if it's x, what would y be? Alright, so that's when we kind of come up with the equation or the function for the line. Alright, so we can start out by filling the values that we do have. So when x is 3, y is 11. Alright, when x is 2, y is 8. When x is 1, y is 5. When x is 0, y is 2. Alright, when x is -1, y is -1. And then when x is -2, y, well, we don't have that one, so don't need that one. Now, you could keep on extending the line to find out what the points are, or the more efficient way would be to find out the pattern. Alright, so looking at here, and it's always recommended to start from 1, 2, 3, 4, because those are easier numbers to work with. When x is increased by 1, y is increased by 3. Alright, so x increases by 1 again, y increases by 3 again. Alright, x increases by 1, y increases by 3. Alright, so that's what we call our constant rate of change. Right, as x is increased by 1, y increases by a certain amount, and then that can help us get our next value. So when x is 4, going from 3 to 4, I know that y will go from 11 to 14, because 11 plus 3 equals 14. Alright, so going from 4 to 5, 14 will go to 17. Alright, now for the next one, we can't do that because it's jumping 10 spots instead of going from 5 to 6. So in this case, it would be more helpful if we come up with the equation, so then we can plug in whatever we want for x, and we can get our corresponding y. Alright, so from our previous lesson, lesson 6, we can use this rate of change to help us get the equation. Alright, so knowing what we know about the equation of a line, which is y equals mx plus b, m being the constant rate of change and b is the y-intercept. Alright, so we have a constant rate of change, which is +3, which means our equation should at least have 3 times x in it. Now, there may be additional numbers we need to add or subtract. We don't know. Well, let's go ahead and plug in an example just to find out. Right? So an easy number to work with would be 0. If we plug in 0 for x, right, that will equal to 0. Now, with our table, it needs to equal to 2. So how do we go from 0 to 2? We would add 2. So this was the initial equation we came up with. Our new equation would need to add that adjustment, which is add 2. Okay, so now if we plug in 0 for our x, 3 times 0 equals 0, 0 plus 2, that will give us the desired outcome. Right? We can plug in another x value to see if we get the same one. So let's go on to the next, let's jump a couple, let's go 3. All right, so if we plug in 3 where x is, y will equal to 11, because 3 times 3 is 9, 9 plus 2 equals 11, and that matches up with our table. So then we know that this is a valid equation. All right, so going down here, we can fill in whatever x is, y would be 3x plus 2. All right, so then we can use that to fill in the rest of our table. So up here, if x is -5, so we can just plug that in into the equation, y will equal to 3 times -5 plus 2, all right, which equals to 3 times -5 is -15. -15 plus 2 is -13. All right, so this should be -13. When x is -3, y will equal to -3 times 3, which is -9. -9 plus 2 will give us a -7. All right, moving down here. When x is 10, y will equal to 10 times 3, which is 30. 30 plus 2, which is 32. And last one, when x is 20, y will equal to 20 times 3, which is 60. 60 plus 2 equals 62. All right, so I can fill that in our table here, and that completes our table. All right, so moving on to question D, 2D, using a table, describe the pattern, which we kind of already did. The pattern is as x increases by 1, y increases by 3. All right, 2E, write an equation for this line in terms of x, and we did that down here, or over here. All right, the equation of the line is y equals 3x plus 2, so that's the answer to 2E. All right. 2F, find the point that has 11 as its x coordinate. All right, meaning in our table, so somewhere in between here, if x is 11, what would y be? We can just plug that in to our equation. All right, so for 2F, so 3x plus 2 is our equation of our equation or function of this table. So if we plug in if x equals 11, right, y will equal to 11 times 3, which is 33. 33 plus 2 equals 35. All right, so the y coordinate is 35, but it wants us to write it as a point. So we need 11, comma 35. Oops, forgot the close bracket there. All right. And 2G is kind of the opposite. It's going to give us the y coordinate, and it wants us to find the x coordinate to complete the point. All right. So this would be in a situation where we solve for x. So y equals -13. Right. What would x be if we have that? All right, so the first thing we gotta do is we need to subtract 2 from both sides, right? Because we want to eventually isolate x to solve for x. I'm just gonna move it over here since there's a little hole there. -13 minus 2, because we want to subtract 2 from both sides. That will cancel that out. I'm left with a -15 equals 3 times x. And now to get rid of the times x, I can just divide both sides by 3. All right, these will cancel out. I'm left with a negative 15 divided by 3, which is negative 5. And put that into coordinate form, negative 5, comma, negative 13. That's our answer for 2G. For number 3, it gives us a function g, which is defined as 2x plus 5. Alright, so g of x equals 2x plus 5, and then it's giving us values for x and wants us to find out what the result is. Alright, so I'm only going to do a, b, and c since the other ones are basically the same thing. Alright, so our function is g of x. Again, g is just the name of the function. Alright, so that could be any other letter or symbol. And the reason why they write it like this is it will make it really easy to write out what we're trying to find. So g of 1, where 1 equals x, where x equals 1, you simply replace 1 with where x is, which is up here. Alright, so 2 times 1 plus 5. 2 times 1 is 2. 2 plus 5 equals 7. So g of 1 equals 7. Alright. 3b, we are to find g of negative 3. Alright, so that means x is negative 3. So negative 3 times 2 is negative 6. Negative 6 plus 5 equals negative 1. Okay, so g of negative 3 equals negative 1. 3c, we need to find g of negative 2. So replace the x with a negative 2. 2 times negative 2 is negative 4. Negative 4 plus 5 equals positive 1. Okay, I'm going to skip ahead to number 5. And if you need help with number 4 is pretty much the same question as number 5. Alright, so you can just watch number 5 to figure out how to do number 4. Alright, so number 5, we have Victor making cakes. $14 is how much the initial cost is for startup supplies. And then for each cake he makes, it's going to cost him $1 on top of the $14. Alright, so the $14 is his fixed cost, meaning that's going to stay 14 no matter how many cakes he makes. And then his $1 per cake is his variable cost, meaning it's going to depend on how many cakes he makes. Right, and then the last part of the question is telling us that he's going to sell each cake for $3. Alright, so for 5a, we need to write an equation representing the total costs to make X amount of cakes. Okay, so 5a, so we have $14 as the initial cost, right, and then each cake he makes is $1. Alright, so for our equation, you have two choices. One, you can come up with the equation from the word problem, alright, or you can make a table, and from the table you can figure out the pattern, and then from the pattern you can come with the equation. Alright, that's basically the same thing as what we did earlier for number 2, except if you're going to make a table, that's going to take some time. So I would try to come up with the equation from the word problem first. Alright, if you think about it, again, $1 for every cake he makes. So if I make X amount of cakes, it would make sense that you're multiplying by the $1. Because if I make 5 cakes, it will cost me $5. If I make 10 cakes, it will cost me $10. Now, no matter how many cakes I make, I'm always going to have the $14 added to it because that is the initial cost, that's the fixed cost. Alright, so if I make 10 cakes or 200 cakes, I'm always going to have that $14. Alright, so that would be our equation. If I want to write that in the proper form, I don't have to write the 1, it's simply y equals x plus 14. Okay, so that's our equation there. And if you want to make a table, we can go ahead and make a table where our x values is on the left and our y values on the right. right? And really we just need probably 3 values would be enough. Alright, so when x is 1, we can just think about it. If we make 1 cake, it will cost us $1 plus the 14 starting cost, so that would give us 15. Right, if we make 2 cakes, that would cost us $2 plus the 14, so that will give us 16. Right, if we make 3 cakes, that will cost us $3 plus the 14, that will be 17. Alright, so it looks like our pattern going from here is +1, over here is +1. Alright, so that is our constant rate of change. So our equation should look like this at least. Right, and then if we plug in our values, we'll see if we need to add or subtract to make up the difference. So if we plug in 1, y equals 1. Alright, so when x equals 1, y is supposed to be 15, so our difference is plus 14. Alright, because that's how we turn 1 into 15 as we add 14 to it. Alright, so we can plug in another value for x. Alright, if x is 2, y equals 16. Alright, that confirms that this is our equation. And you can see it's the same thing that we came up over here, but you would need to go through this process to get that. So if you can get it from the word problem itself, that will save you some time. Alright. Now for 5b, we need to come up with an equation for the revenue earned by selling X amount of cakes. Alright, so going back to the problem, for each cake he sells, he's going to sell for $3. Okay, so the amount of money he's going to make, y equals $3 times the amount of cakes. So if he sells one cake, he'll make $3. If he sells 2 cakes, he'll make $6. Alright, so same thing. If you can't come up with that equation, you can make a table, find a pattern, and then get the equation from there. Okay. So now that we have the 2 equations, the next couple questions will be a lot easier because we can just plug it into our equation. 5c wants us to find how many cakes he can make for a cost of $30. Alright, so this is solving for x. So we're using, oops, I forgot to box this. Alright, so we're using this equation because we're trying to find out how many cakes he can make for a cost of $30, not how much he can earn. Alright, so if the cost is $30, if y is 30, what would x be? Alright, and then this is a pretty straightforward solving. If I subtract 14 from both sides, these will cancel out, and I'm left with 30 minus 14, which is 16. So x will equal to 16 cakes. Alright, he can make 16 cakes for a cost of $30. Alright, next question. 5D, how many cakes does he need to make to produce a revenue of $48? Alright, so meaning how many does he need to sell? Alright, so 5D, again, if y equals 48, what would x be? But this time we're using this equation because that's our revenue equation. Alright, to solve for x, I would divide both sides by 3. Alright, these will cancel out. I'm left with 48 divided by 3, which is, see, 16. Alright, and if you can't do that in your head, you would use long division. Alright, to get 16. Alright, so 16 is the amount he would need to, the amount of cakes he would need to make to sell for $48. Alright, so next question, 5E, it wants us to plot the total cost and revenue. So we should have 2 separate lines. Alright, and to save time, I already did that. And here's our graph. Let's see if I can zoom in a little bit. Okay, so if you see my x-axis, Right, each square is 1, but for my y-axis each one is 2, so that way I can save a little space. Alright, so the black line is our line for the cost. Alright, here's our equation, y equals x plus 14. So if you look, if when x is 0, y would be 14. When x is 1, y would be 15. When x is 2, y would be 16. Alright, so we create that line, that's what that looks like. The red line is the line for our revenue, y equals 3 times x. So if you look over here, when x is 0, y would be 0. When x is 1, y would be 3. When x is 2, y would be 6. Alright, so there's our two lines graphed on the same coordinate plane. Now last, for question 5F, it wants us to identify where do the two graphs intersect and what does the point of intersection mean. Right, so they intersect at this point, which is 7, 21. Alright, and can you always double check if that point is correct to plug it into the equation and see if it works out for both equations. Alright, so if x is 7, 7 times 3, y will equal to 21, and that's correct. Over here, if x equals 7, 7 plus 14, y will equals to 21, also confirmed. Okay, so that point is correct, and that will represent the break-even point. Meaning, he would need to make at least 7 cakes. So if he sells all 7, he will cover all his costs. So he would make $0. Right? So as long as he sells more than 7, he would make money. And obviously, the more he makes, the more money he's going to make. Right? Because his cost is this line right here, where it's going to go up. Obviously, the more cakes he makes, the more the cost is going to be, but it's going up at a slower rate. Whereas if he makes more cakes and sells more cakes, he would make money at a faster rate. Right? So the more he sells, the more the difference between the two lines are going to have. Right? So then that means the more money he's going to make. Alright, for number 6, it's very similar to number 3, where we are given a function. Alright, this time it's labeled function f, and it wants us to plug in different x values to see what the outcome is. Alright, so I'm going to do a couple. I'm going to do 6a and 6d. Okay, so 6a is f of 0. Alright, in our equation, maybe I should have wrote the equation. Our equation, if you don't have it in front of you, is f of x equals the absolute value of x minus x. Okay, so for f of 0, I can plug in 0 for where there is a x. Right, so I have the absolute value of 0 minus 0. Absolute value of 0 is 0. 0 minus 0 equals 0. Okay, so that might not have been a good one to do. Not as helpful. Let's go and do another one. 6. Let's do 6b. So that way you have a actual number to work with. All right. So you plug in 4 for where x used to be. Leaves us with absolute value of 4 minus 4. Alright, the absolute value of 4 is 4, and then if I subtract 4, I get 0. Alright, 6. Let's do 6d. 6d, we are given a negative number for x. Alright, and let's see how that changes the equation or the outcome. Alright, so if I plug in negative 3 minus negative 3, the absolute value of negative 3 is a positive 3. Remember, the absolute value basically changes every number to a positive number. And then if I subtract a negative 3, that ends up being adding a positive 3. And remember, when we subtract, we always add the opposite instead. Right, so if we add the opposite of -3, which is +3. So 3 plus 3 equals 6. And our answer is 6. Right, so knowing how absolute value behaves, you can pretty much anticipate any positive number here, you're going to get a 0. And any negative number, you're going to get double that number, right? And that's always going to be the case. So if when you graph this function, you would get a pretty interesting line. Okay, number 7. Logan rents a boat. They charge $55 per hour with a deposit of $75. Okay, so the $55 is the variable cost. It means it will change depending on how long you rent the boat for. And the deposit is the fixed cost. That's going to happen no matter how long you rent it. So you rent it for 1 hour, you're still going to need to pay the deposit of $75. You rent it for 10 hours, it's still going to be $75. All right, so it's very similar to the question we had earlier. So for 7a, it wants us to write the function of the cost y in terms of the number of hours x. So basically the equation. And again, if you cannot figure out from the word problem that y equals 55 times x, because however many hours I have, I need to multiply by the cost per hour, and you add 75, the fixed cost, because that's going to happen no matter what, regardless of what x is. All right, if you can't figure that out, then you would need to make a table, and then from the table you can figure out the pattern. From the pattern you can come up with the equation. Okay, but that is our function. All right, remember, anytime they're asking for a function or rule or equation, it basically means the equation. All right, 7b. Logan goes deep sea fishing from 8 a.m. to 2 p.m. How much does he have to pay? All right, so from 8 to 2, that is 6 hours. All right, so you just plug that into your equation. Y equals 55 times 6 plus 75. All right, and I'm sure for most you probably need to work this out. All right, 6 times 5 gives me 30. 6 times 5 gives me 30, but then I need to add the 3, so I end up with 330. All right, so that equals 330 plus 75, and that will equal to 405. All right, if that's not clear, you can add them up here. 0 plus 5 is 5. 3 plus 7 is 10, carry the 1, 1 plus 3 is 4. Alright, so $405 is your answer. Alright, 7C, if they are charged $625, how long did they use the boat? Alright, so this is going backwards. It's giving you the total cost, 625, and now you're trying to figure out what x is, which is how long you rent the boat for. All right, so the first thing we need to do is subtract 75 from both sides. All right, these get canceled out. 625 minus 75 is 550. All right, 550, 55x. All right, and then if I divide both sides by 55, these cancel out. I'm left with x equals 10. And again, if any of these you can't do it in your head, then you would just need to work it out on the side. All right, so 10 hours is our answer. All right, and to double check is always a good habit of just plugging that 10 back into the equation and see if you end up with 625. So 10 plug back into x, 10 times 55 is 550. 550 plus 75 is 625. Okay, for number 8, we need to plot the following points and translate each by using the rule add 5 to the x coordinate and add -2 to the y coordinate. Alright, so to write that out, we're supposed to add 5 to x and add -2, which is the same thing as -2 to y. Alright, so whatever x values we have, we add 5 to it, and then whatever y values we get, we subtract 2. So you have two ways you can do this. If it's asking you to plot, then you would need to plot it, but it is possible to do this without plotting the points on the coordinate plane. You can, so for example, for 8a, we have 4, 4. Alright, if we plug in 4 where x is, we would get 9. If you plug in 4 where y is, we would get 2. And there we will get the new point after you translate it. Okay, so if you don't need to plot the point, that would probably be the fastest way of getting that. Now, it does say we need to plot, so we're going to go and do that. 4 is right here, and let's just label that as A, since that's question A. And if we were going to translate it, we can use what we just calculated, which is 9, 2. That is where our new point, we're going to call that A prime. Alright? Now, if you don't understand how this works, you can use the graph to help you. Right? If you're more of a visual person, and then just go ahead and move like literally move the point on the coordinate plane. So using a rule, x plus 5 means we are moving it to the right 5 spaces. Y minus 2 means we are moving down 2 spaces. Right? Positive is always right or up. Right? Negative is always left or down. Now, how do we know if it's left or right or up and down? Well, our x values is our x-axis, which is going horizontal, so that's left and right. Our y values is on our y-axis, so that is going vertical, up and down. All right, so that there you have a couple of things that can remind you of the direction there. All right, so if we move A 5 spaces to the right, 1, 2, 3, 4, 5, and then we move 2 spaces down, we will arrive at the same place. All right, so those are your two ways of doing that. All right, so 8b is 0, 4. So 0, 4 is right here. Label it B. All right, so let's do the moving method. We move it over 5, 1, 2, 3, 4, 5, and move it down 2, 1, 2. All right, so here's our new point. B prime. Okay, if we want to actually calculate it, simply plug in 0 into where x is, you would get 5. You plug in 4 where y is, you would get 2. Alright, so 5, 2 should be the new point, and if you look over here, that is exactly where P prime is. Alright, next one is C, which is at -4, 1. Alright, -4, 1 is right here. That's where C is. Right, if we move it over 1, 2, 3, 4, 5, and move it down 2, we would arrive at our new point, C prime. Right, and if you want to use the math method, plug in -4, you would get 1, and you plug in 1, you would get -1. So 1, -1 is right there. Right, so depending on what you're more comfortable with, I would suggest using that method, and you can always use both to double check your answer. Alright, for number 9, we are reflecting now. We're reflecting the point about the x-axis. Alright, so 9a, we have 4, 4, which is right here. Alright, we'll label that A. And since we're reflecting it across the x-axis, which is here, that means it's going to be somewhere in this area. All right. Sometimes it's easier for people to visualize it side to side. So if this is the midline, and you're trying to have a mirror image of that point, it would maybe be a little bit easier to visualize that it's going to be on this area. Right? However far away this point is from the line of reflection, that's how far away it needs to be on the other side. So for example, if it's all the way over here, then your reflection point would be the same distance away. If it's really close to the reflection line, then the reflection point would be really close also, right? And since we have the grids, we can find out exactly how far it is. It is 1, 2, 3, 4 away, so it should be 1, 2, 3, 4 away the other direction, right? And if you want to flip it back right side up, that's the same thing. If you can visualize it going up and down, 1, 2, 3, 4, 1, 2, 3, 4. All right, so that is our new point, A prime. All right, let's do another one. B is 3, negative 6. All right, so that is right here. Okay, and now it's kind of the opposite now. Now we're reflecting upwards, all right, because we still want to reflect it over this line. Okay, so it is 1, 2, 3, 4, 5, 6 spots away from the reflection line. It would need to be 1, 2, 3, 4, 5, 6 spots away the other direction. All right, so this would be B prime. All right, and I'm not going to do C and D because they're pretty much going to follow the same thing. The only thing I want to mention is you need to be careful what line it's telling you to reflect it over. So if it's reflecting over the y-axis, which is the vertical axis, then you would be going side to side. All right. So if I'm reflecting A over the y-axis, I would be going the same distance that way. Okay, number 11, we need to write out the first 5 terms of each sequence. So 11A, we have n plus 5. All right, so the first term equals 6. Okay, you place the n with the 1. Second term equals 7. Third term equals 8. And soon enough you can even just use the pattern, which is increases by 1 to get the next term. Alright, 11B. The sequence is 3n minus 2. Right, so the first term equals to 3 times 1 minus 2, which is 1. The second term, 3 times 2 minus 2, which is 4. And again, you can use the pattern, which is it's going to increase by 3 each time to get the next one, which is 7, 10, and 13. All right, if you want to work it out, just to double check, 3 times 3 minus 2 will get you 7. All right, so 11C, got 5n plus 8. After you find the first term, 5 times 1 is 5, 5 plus 8 equals 13. Again, you can use what you know in terms of this equation. 5 is the constant rate of change. You simply add 5 to the previous number. So 13 plus 5 is 18, 18 plus 5 is 23, 23 plus 5 is 28, 28 plus 5, 33. That'll give you the first 5 terms. Alright, and if that's too hard to understand, you can still work it out, work each term out one by one. Right, but just understanding how the equation works will save you a lot of time. Alright, number 12, we're giving the actual terms of the sequence, and then we need to determine the rule, right? And also write out the next two terms. All right, so for A, we have 2, 7, 12, and 17. All right, each time the next number is increased by 5, so the next two terms should be 22 and 27. All right, now to get the equation, whatever it's increasing by, that's the constant rate of change. That would be what we are multiplying in with. All right, now we simply just need to find out what other modification we need to do to it. So if you plug in the first term, A of 1, it should equal to 2. All right, but if you actually plug it in here, we get 5. All right, so how do we turn 5 into a 2? We would need to subtract 3. So our new equation should be 5 times n minus 3. All right, so we can plug in a different term just to double check. And let's plug in the second term. All right, we should get a 7. All right, so 5 times 2 minus 3 will give us 7. So that checks out, and that means that this equation works.